In 1932, a brand new Cadillac V8 would set you back $20,700. That's about $60,000 in today's money. The engine alone, with its overhead valves and precision machining, cost more to build than most people earned in a year. But that same year, something impossible happened. Ford started selling V8-powered cars for $460, not inline fours, not sixes. Full 8-cylinder engines that could embarrass Packards and Lincolns at stoplights. This is the story of how Henry Ford's engineers created the most democratic performance engine in history and accidentally built the foundation for hot-rodding, NASCAR, and modern American car culture. Picture this. It's March 1932, and America is drowning in the Great Depression. Unemployment hits 24%, banks are failing daily, breadlines stretch around city blocks. The luxury car market has completely collapsed. Cadillac sales dropped 84% in 3 years. Meanwhile, at Ford's Rouge complex in Dearborn, Michigan, engineers are attempting something the entire industry says is impossible: mass-producing a V8 engine cheap enough for the common man. Not a simplified V8, not a compromise. A real, fire-breathing 8-cylinder that could be stamped out like Model T parts. The automotive establishment is laughing. They're about to stop. Here's what made this engine legendary. Ford didn't just make a cheap V8. They revolutionized how V8s could be built, creating an engine architecture so brilliantly simple that shade tree mechanics could rebuild it with basic tools, yet so fundamentally sound it would power everything from farm trucks to Indy cars for the next 2 decades. To understand the magnitude of Ford's achievement, you need to grasp what V8 ownership meant in 1932. Owning a V8 was like owning a private jet today. It wasn't just about speed, it was about status, sophistication, and engineering excellence that separated the wealthy from everyone else. Cadillac had been building V8s since 1914. Their 1932 engine featured overhead valves, 5 main bearings, and required 97 separate casting operations. Each engine block alone took skilled workers 3 days to machine. The result was smooth, powerful, and completely inaccessible to 99% of Americans. Lincoln, ironically owned by Ford, built a V8 that was even more complex. Individual cylinder barrels, forked connecting rods, a price tag that started at $4,400. Packard's straight 8 used 9 main bearings and precision tolerances measured in 10,000ths of an inch. These weren't just engines. They were mechanical jewelry, hand-assembled by craftsmen who'd apprenticed for years. The idea that Ford could mass-produce something comparable for 1/6 the price wasn't just ambitious, it was considered delusional. But Henry Ford had an obsession. He'd been secretly developing a low-cost V8 since 1929, burning through $50 million in development costs while the Depression ravaged his company's sales. Ford's motivation wasn't entirely noble. He was getting destroyed by Chevrolet's new 6-cylinder, which offered smoothness his 4-cylinder Model A couldn't match. But instead of building a 6, Ford decided to leapfrog everyone. If he could democratize the V8, he'd make every other manufacturer's lineup look obsolete overnight. The engineering challenge was staggering. Traditional V8s required complex casting techniques that only a handful of foundries in the world could execute. The cylinder blocks had to be cast in multiple pieces, then precision machined and assembled. The crankshafts needed 5 or more main bearings to handle the harmonics. The whole assembly required skilled workers and couldn't be rushed. Ford's engineers had to throw out every assumption about V8 design and start from scratch. The breakthrough came from Ford's chief engineer, Carl Schultz, and a secretive team working in what they called the Blue Room, a locked laboratory where even other Ford executives weren't allowed. Their radical solution: cast the entire V8 block, including all 8 cylinders and the crankcase, as a single piece. No automotive manufacturer had ever attempted this. The casting would be so complex that when Ford approached outside foundries, They were told it was metallurgically impossible. The internal cavities couldn't be properly formed. The cooling would be uneven. The whole thing would crack. Ford's response was typically Ford. They'd figure it out themselves. The team developed an entirely new casting process using green sand molds with 54 separate cores to form the internal passages. The pouring technique required molten iron at exactly 2,650 degrees Fahrenheit, flowing at a precise rate to prevent air pockets. 1 degree too hot, and the casting would be porous. 1 degree too cool, and it wouldn't fill completely. They went through hundreds of failed attempts. Entire blocks would crack during cooling. Others would have core shift that made the cylinder walls too thin. The scrap pile grew so large they had to build a new furnace just to remelt the failures. But here's where it gets brilliant. Instead of overhead valves like Cadillac, Ford used a flathead design, valves in the block beside the cylinders. This wasn't cutting edge. It was deliberately retrograde, but it made everything simpler. No complex valve train, no rocker arms, no overhead camshaft. Just a single camshaft in the block operating the valves directly through short tappets. The head was just a flat piece of iron with combustion chambers cast in. You could remove it with basic tools and resurface it with a piece of sandpaper on plate glass. The specifications were impressive for any V8, let alone one costing a fraction of the competition. Displacement, 221 cubic inches, achieved through a 3.0625-inch bore and 3.75-inch stroke. Compression ratio, 5.51, low by today's standards but typical for the era's 70-octane gasoline. The L-head combustion chambers were far from ideal for breathing, but they were incredibly robust. Power output, 65 horsepower at 3,400 RPM and 130 lb-ft of torque at 1 to 250 RPM. Compare that to Chevrolet's six-cylinder making 60 horsepower from 194 cubic inches, or the Model A's four-cylinder struggling to produce 40 horsepower. The engine used only 3 main bearings instead of the 5 or 7 in luxury V8s. This should have been a disaster. V8s generate complex harmonic vibrations that typically require multiple main bearings to control. But Ford's engineers discovered that by carefully balancing the crankshaft and using a specific firing order, 154-86372, they could minimize the vibrations enough to make 3 bearings work. Was it as smooth as a Cadillac? No. But it was smoother than any 4-cylinder, and that's all that mattered. The ignition system was revolutionary in its simplicity. Instead of a complex distributor with 8 individual wires, Ford used a unique distributor cap that sat directly on top of the engine, firing 2 cylinders simultaneously, one on compression, one on exhaust. The spark on the exhaust stroke did nothing, but it eliminated half the distributor complexity. Simple, cheap, brilliant. Cooling was handled by a high-capacity water pump driven directly off the camshaft, circulating coolant through passages cast into that one-piece block. The passages were designed with deliberate restrictions that forced coolant to flow evenly around all 8 cylinders, critical since the middle cylinders in a V8 typically run hotter. No expensive water manifolds, no external plumbing, everything internal to that single casting. Now here's the kicker. Ford's manufacturing process was just as revolutionary as the engine design. While Cadillac workers spent 3 days machining a single block, Ford's automated transfer machines could complete one every 90 seconds. The Rouge plant's production line featured 47 different machining stations, each performing specific operations as the blocks moved continuously through on conveyors. Boring the cylinders, facing the deck, drilling oil passages, all happening simultaneously on different blocks. The entire machining process, from raw casting to finished block, took 90 minutes. Cadillac's took 72 hours. The assembly was equally streamlined. workers could install a complete Flathead V8 in 58 individual operations, each designed to take less than 1 minute. The engines rolled off the line at a rate of 1 every 3 minutes during peak production. By the end of 1932, Ford was building 3,000 V8s daily. More V8s in a single day than Cadillac built in a month. But Ford's biggest innovation might have been in quality control. Every single engine was test run for 15 minutes before installation. Not a sample, not random testing. Every single engine. They'd break it in, check for oil pressure, listen for bearing noise, verify the ignition timing. This was unheard of in mass production. It's why early Flatheads, despite their simple design, were remarkably reliable. You could buy a Ford V8, drive it off the lot, and immediately cruise at 75 mph, something that would destroy most four-cylinder engines of the era. The market response was volcanic. When Ford unveiled the V8 at the 1932 New York Auto Show, they took 50,000 orders in the first 48 hours. Dealers couldn't keep them in stock. The base Model 18 with the V8 cost just $460, only $50 more than the four-cylinder version. For perspective, that's like paying an extra $100 today to upgrade from a four-cylinder Accord to a V8 Mustang engine. The value proposition was insane. But here's where the story gets really interesting. The Flathead simplicity made it the perfect platform for modification. That head could be milled for higher compression. Those ports could be relieved and polished. Multiple carburetors could be adapted easily. The robust bottom end could handle significant power increases. Within months of release, speed equipment manufacturers were selling hop-up parts. Edelbrock, Offenhauser, Wyand. Entire companies were born just to make Flathead parts. The racing world took notice immediately. In 1933, a nearly stock Ford V8, driven by Louis Meyer, averaged 104 mph at Indianapolis, finishing second. By 1934, Flathead-powered cars were dominating dirt tracks across America. The engine's low-end torque made it perfect for oval racing. Its simplicity meant you could rebuild it in the pits. Its availability meant everyone could afford to race. This wasn't aristocratic European Grand Prix racing. This was democratic, working-class American speed. Let me put the performance in perspective. A 1932 Ford V8 could hit 78 mph, faster than most American cars wouldn't match until the 1940s. 0 to 60 took about 16 seconds, which sounds slow today, but was genuinely quick for 1932. A contemporary Chevrolet 6 needed 24 seconds. The Ford could out-accelerate Buicks costing 3 times as much. It wasn't just fast in a straight line either. The V8's weight distribution, with the compact engine sitting low in the frame, gave the lightweight Ford surprisingly good handling. Law enforcement noticed too. Police departments nationwide started ordering V8 Fords because criminals were using them. It became an arms race. Cops needed V8s to catch robbers in V8s. Clyde Barrow of Bonnie and Clyde infamy famously wrote Henry Ford a letter praising the V8's speed and reliability for evading police. John Dillinger preferred stolen Ford V8s for bank robberies. The FBI started requisitioning them for pursuit vehicles. The Flathead literally changed how crime and law enforcement operated in America. But the engine's real impact was cultural. For the first time in history, genuine performance was accessible to the working class. A factory worker, farmer, or small business owner could own the same basic engine architecture as a wealthy industrialist. Sure, the Cadillac was more refined, but the Ford could embarrass it at a stoplight. This democratization of speed created something uniquely American, hot rod culture. By the late 1930s, Southern California dry lakes were covered with stripped-down Ford V8s, pushing 100 mph. Kids would buy worn-out models for $25, pull the fenders and hood, add high-compression heads and multiple carburetors, and suddenly they're running 110 km/h at El Mirage. The Flathead became the people's race engine, You didn't need an engineering degree or machine shop. With basic tools and junkyard parts, anyone could build a respectably fast car. The technical evolution was remarkable. By 1939, Mercury's version displaced 239 cubic inches and made 95 horsepower. Aftermarket manufacturers offered everything from superchargers to overhead valve conversions. Boring and stroking could take displacement over 300 cubic inches. With aluminum heads, dual carbs, and headers, 150 horsepower was achievable, double the original output. Racing versions were pushing 200 horsepower by the early 1940s. World War II only enhanced the Flathead's reputation. Ford built over 500,000 V8s for military vehicles, trucks, armored cars, boats, generators. GIs learned to maintain them in combat conditions with minimal tools. The engine's simplicity made it perfect for battlefield repairs. A generation of American men returned home knowing exactly how to work on Ford V8s. They became mechanics, racers, and the founding fathers of the performance aftermarket industry. The numbers tell the story. Between 1932 and 1953, Ford built over 20 million Flathead V8s in various displacements. 20 million. It powered everything from pickup trucks to French sports cars. The French Ford subsidiary used Flatheads until 1954. In Brazil, they built them until 1958. Hot rodders were still building race engines from Flathead blocks into the 1970s. The last competitive Flathead-powered dragster ran in 1968, 36 years after the engine's introduction. So what was actually going wrong? The Flathead's fundamental limitation was breathing. Those L-head combustion chambers created a tortuous path for intake and exhaust gases. The exhaust passages ran through the block, making them prone to overheating. The valves sitting beside the cylinders limited their size. By the late 1940s, overhead valve engines from Oldsmobile and Cadillac were making more power from less displacement with better fuel economy. The Flathead had reached its development limit. Ford knew this. Engineers had been developing an overhead valve replacement since 1948. When the Y-block OHV V8 arrived in 1954, it made 130 horsepower from 239 cubic inches versus 110 from the last 255-inch Flathead. Better breathing, higher compression, more efficient combustion. The Flathead was obsolete overnight, at least in new cars. But here's the thing about the Flathead. It refused to die. Hot rodders had 20 years of accumulated knowledge. Speed shops had warehouses full of parts. Every junkyard in America had Flathead blocks for $10. The engine became more popular after production ended than during its manufacturing run. The 1950s hot rod explosion was built on Flathead V8s, those gorgeous 32 Ford Roadsters in American graffiti, Flathead-powered. The birth of NHRA drag racing, dominated by Flatheads until the mid-1950s. The engine's influence shaped American automotive culture in ways still visible today. The entire speed equipment industry, companies like Edelbrock, Holley, and Isky, grew from making Flathead parts. The tradition of small block V8s in lightweight cars started with the Flathead. The very concept of taking an ordinary car and making it extraordinary through engine modifications, that's the Flathead's gift to American culture. Think about that for a second. In 1932, performance was exclusive to the wealthy. By 1942, any kid with mechanical aptitude and determination could build a fast car. This wasn't just democratization of speed, it was democratization of automotive engineering itself. The Flathead taught two generations of Americans that engines weren't mysterious black boxes maintained by specialists, but comprehensible machines that responded to intelligence and effort. Modern engine technology has obviously surpassed the Flathead in every measurable way. A new Honda Civic makes more power per liter than the best racing Flatheads ever achieved. Modern V8s are smoother, more powerful, more efficient, and more reliable. but they're also complex beyond what most people can understand, let alone modify. You can't rebuild a modern direct injection V8 with hand tools. You can't modify its computer-controlled systems without specialized knowledge and equipment. The Flathead represents something we've lost: accessibility. It was an engine designed not for maximum performance or ultimate refinement, but for regular people to afford, understand, and improve. It turned mechanics into engineers, teenagers into racers, and America into a nation obsessed with going fast. Every modified car, every drag strip, every speed shop in America owes something to Henry Ford's simple, revolutionary V8. Today, a rebuilt Flathead costs more than a modern crate engine, making 3 times the power. Original speed equipment sells for thousands at auction. Restored 32 Fords with Flatheads command 6 figures. The engine that democratized performance has become a wealthy collector's trophy. Ironic, but perhaps inevitable. What started as the people's V8 has become mechanical art, valued not for what it does, but for what it represents. The Flathead story is really America's story, taking something exclusive and making it accessible, turning luxury into democracy through sheer ingenious determination. It wasn't the best V8 ever built. It wasn't the most powerful, smoothest, or most advanced. But it was the first V8 that belonged to everyone. And in transforming American automotive culture from an elite pursuit into a democratic passion, the Flathead V8 might just be the most important engine ever built. What's your Flathead story? Whether it's a grandfather's hot rod tale or your own project car, drop it in the comments below. And if you enjoyed this deep dive into the engine that democratized American speed, hit that subscribe button. We're just getting started exploring the machines that changed history. Until next time, keep those engines running, and remember, sometimes the simplest solution is the most revolutionary.